buy a Milwaukee fan
What?
for yourself.
What about Milwaukee?
Go buy a Milwaukee fan.
Well, they have a big one of those huge fans that are there, but it doesn't help when the humidity's 80%.
Well, you shouldn't be in Houston.
I know. Good evening, everybody. Welcome to Advanced Refrigeration Podcast. You're here with your host, Brett Wetzel and Kevin Compass. Yeah, like I said, I was in Houston. I'm in Houston this week, working on the training center.
It is disgusting out there right now.
Oh my God, it's Friday. It was 97 today, and like I don't even know what the fucking humidity is, but it's horrible, just
It's
horrible.
like Texas, Florida.
Yeah, that's essentially what it is.
Yeah,
Actually,
no fun. I spent like a month on a Costco roof out there.
we have one of the guys from the learning and development team who helps us with some of our safety training and some of that stuff. I actually have him out here because he was a technician. And he writes a whole bunch of technical documents on based off the equipment that we work on. So this is neat for him because he never really got to work on like rack stuff. But he knows curriculum and he knows refrigeration, HVAC, just not to like the rack extent. So like this is actually really cool for him getting to wire all this shit in and kind of understanding certain things, why the way why we use indoor photo cells, why we use pulsing anti-sweats and shit like that. So a lot of the stuff we're just going over, and he's just learning as we're going through the wiring and stuff. But basically, I have him wiring up all the panels, so I got to get that shit done. I'm trying to get some VRF stuff in. I got to do 2 conversions on 2 natural gas rooftop units and switch them over to LP. Just got a whole bunch of stuff that's going to be available for the light commercial stuff. But where are you at? Where are you at this week? You at home?
Yeah, I'm at home, just kind of playing cleanup and just trying to get caught up on projects before like everything just goes to absolute shit.
Are like the area that you're in? Are you affected by all the fires and shit up in Canadian land?
No,
No,
Canada's on fire.
seriously?
I don't watch the news.
Oh, okay, yeah. Like there's places of I think New Jersey, I think, was on fire too, and like it's affecting the air quality. Like it's that bad in New Jersey where it's putting that much sediment in the air that at times the sky looks orangish red. You didn't see shit on social media, nothing.
No, I really haven't been like paying attention lately. I've been living in my own personal hell of like trying to get all these jobs caught up and like quoted and figure out how I'm gonna play the next 6 months of quota work we have.
Sweet, a whole bunch of changeovers or what?
Yeah, a whole bunch of changeovers. A few of them are out of town, which I'm not looking forward to.
Where are you gonna be?
So, like Southern Illinois, kind of like it's not like super far, but it's like far enough where like I'm not gonna drive every day. Like I'm not gonna drive 3.25 hours every day, even though I drove that home today.
Damn.
So I mean, it's kind of like that weird spot. And then I have some like out of town stuff, and I'm supposed to possibly go to California next week.
Really? Whereabouts?
I haven't asked my wife yet, so I did the Bay Area. So they're doing Costco. They're doing a Costco CO2 startup. So I don't know. It's everything's chaos right now. There's like no help. It's just everything's on fire.
Everything's always on fire.
Well,
Always.
yeah, and then this is like all these like things that were back ordered like all showed up at the same time, and now everybody's like, start this project. It's like everybody wants their projects to start at the same time, and it's just like, no.
This one office cat was like, "You guys are busy all year round." I'm like, "Yes." He's like, "It doesn't slow down in the wintertime." I'm like, "No." Like, no.
It does like to a point, but like
Well, I mean, when it gets super cold, like fucking up in your area, when everything just grenades because it goes all the way down to negative 20 some. And same thing here in Texas. I mean, like the temperatures get down to 10 degrees and shit just goes awry. Like, even though they have holdback valves, don't typically 7/8 of the time they don't have to be concerned with holdback and all that other shit because it doesn't get below 50 or you're running on the cusp, right? But then when you get those snaps where it gets down to like 0 and 10 degrees, fucking forget it. It's over. Game over.
yeah, it's just been like chaotic here. Like it's all these, like, there was like 2 years worth of projects that got like pushed and pushed and pushed, and all of a sudden, like, now everything's starting to like come in, and it's just like bam, here's like 2 years worth of equipment showing up, and everybody's like, okay, start this project, and I'll start this project.
And then you have other shit to do that gets on top than that, right?
Yeah, so it's just like I'm just exhausted at this point, like mentally just drained at this point.
So that's why I think people with ADHD do really, really well in this trade because their attention's always like, oh, look over here. Nope. Oh, over
Yeah.
here. Nope.
Uh,
Over here.
and then like that NASCAR thing's coming to Chicago, so it's making my life even more miserable because like
Oh, shit.
they're like going around like city streets and welding down sewer caps and like stuff like that. Like,
Wait a minute. Wait a minute. NASCAR?
yeah, they just did it in Detroit. Now it's in Chicago. Like they're doing it on like the 4th of July weekend. I think they do some like in like inner city like hood rat run.
Oh, so it's not like NASCAR. It's not
Well,
like,
it's like NASCAR. Like they're doing like this. Like they go around. I don't know. I'm not exactly into that, but like they are like blocking off city streets. They're like repaving parts of roads. Like it has just made traffic an absolute nightmare. And of course, like a lot of what we're doing right now is downtown stores. So everything is like affected by it. Like parking sucks. Like there's like road shut down everywhere. Just double the traffic on back roads.
just sounds like a whole bunch of funness.
Yeah, so I can't wait till that's over. But tonight, guys, I want to talk about something a lot of guys struggle with and a lot of apprentices severely struggle with, and that's reading, interpreting, and the easy way to figure out wiring diagrams.
Well, I think to start, I mean, I think one of the things that has to be discussed is knowing what each one of the symbols means, right? And then that's it. It's kind of difficult to do via audio, but like learning what each one of the symbols actually means is going to help you on how that thing is drawn on there, right? So remembering that typically most schematics that are drawn are with no pressure and no energy applied. So essentially, if you have a system that has a low pressure switch, theoretically it should be open, right? Because I mean, if it has no pressure in the pipe, it should be theoretically written open. That would be my thought. And then figuring out like what some of these symbols mean, because you have one that looks that's a pressure switch, right? It represents a bellows, but depending on where that line is, where it actually either sets on the two circles that make up the sets of contacts, depending on how it's set is dependent on what it's going to do, right? So if you have a pressure switch that's set right on top of the other circle that it connects to for the other connection, that would basically be a open on rise, right? Because as the pressure increases to rise, it would basically open up. So that would be a high pressure switch. If it was drawn the other way, it could be interpreted depending on where it's connected. It can be interpreted as a fan cycle switch, or it could be also interpreted as a low pressure switch. So, like knowing these symbols and what they are, as far as the temperature, what the temperature sensor one looks like, the thermostat, what that looks like, with the pressure, any kind of disconnect, fuses, solenoids. Just getting yourself familiar, taking 15 minutes to just to scope over the paperwork. I know Zero Zone has an incredible, like in almost every single one of their books, they have the first 2 or 3 pages of their whole paperwork typically on all the mechanical drawings and stuff goes over like every symbol and every, oh my god, I can't think of the word, analogy. No, that's not it.
Yeah, I mean, yeah, you're right on analogy, what that symbol means to them. Like,
Yeah.
that's the one thing you gotta kinda watch. Some manufacturers do things a little differently. They may call things certain different stuff, so try to find a legend, but like Brett said, like, start, especially new guys, start by learning all the symbols. I mean, there's a lot of them. There's gotta be, what, hundreds, Brett? Probably?
Oh,
I mean,
100%. But that's the thing, like as long as like how it's drawn, a lot of times you can like you once you start getting accustomed to all these different ways that it's drawn, you can kind of figure out, okay, well, the way that that's laid, you can figure out the theory on how that control circuit is supposed to work based off of how those symbols are fucking drawn, right? So if you get
Correct.
accustomed to that high pressure switch laying on the other top of the connection, you know that that is a safety style switch, right? So basically, if the pressure continues to increase, it's going to open up and then open up the safety. So, like I said, getting really familiar with those symbols and other manufacturer symbols, and you're gonna figure out the theory on how the thing is supposed to work based off of what has to happen first before this thing turns on, right?
Correct. And like, I mean, you're probably going to see the same like 10 to 15 symbols over and over and over again. Let's be honest here. Like a lot of what we do in like the HVAC, our industry, like it's going to be the same symbols over and over again. You're going to have pressure switches, which you're going to have the bells and the lines. You're going to have temperature, meaning like thermostats. You're going to have disconnects. You're going to have like switched switches, fuses, relay contacts, stuff like that. Like you're gonna have the same symbols over and over again. You're not gonna have some of these crazy symbols you see in some of these other diagrams, but you're gonna have some of these. They're more basic symbols, but you're gonna see them over and over again. So actually looking at like what a normally open switch looks like, what a normally closed switch looks like, looking at all those will greatly help you as you're going through this. Now, when it comes down to wiring diagrams, there's a couple different ways they can write it. There's line diagrams, there's ladder diagrams. So a ladder diagram would have the legs of power coming down the sides, and all your loads and your safeties and your switches are all going to be in the middle. Would have like L1 and L2 on each side, and you're going to have everything in the middle. Generally, what we see is ladder diagrams. Is a lot of what we see. Ladder diagrams, I feel, are easier for guys to troubleshoot because there's point A and point B are on the sides. So, and then everything's in the middle. Me personally, I think it's easier to troubleshoot ladder diagrams. What Brett's showing on the screen right now is a ladder diagram. So everything is in between the two sides. You got your rungs. Each rung is a different function on here, whether it's a line or load or it's a switching circuit or a safety circuit. Everything starts from point A and ends on point B, meaning you got your L1 here, your first leg of your control power that you're switching, and you got L2 over here that's feeding the other leg of your control power that's feeding generally your devices.
Hmm. And so, like, if you look at the schematic right here, right, these are auxiliaries on every single compressor for the medium temp rack. So, if God forbid one of these, if none of the compressors are running, if you look, it basically is going to stop any power from going to this relay right here. So, I mean, just following down the line, and a lot of these schematics are really great because some of these will even tell you what part of the program that this relay is activating for certain other devices that you have on here. I'm going to try to look up that zero zone one real quick. Go ahead.
Yeah, so a lot of what you guys are going to see as you get more complicated, you get into these line diagrams, and line diagrams get extremely more complicated. I mean, there it depends on the manufacturer. I mean, you could have wiring diagrams that are pages long. You're not going to see that with ladder diagrams. Everything's going to be in that ladder. You may have more pages of a ladder diagram, but line diagrams can be across multiple pages. Now, generally, from what I've seen, when you get into that kind of stuff, a lot of what gets written on there gets written with there's lines and they're written up in a sense like it'll be like line 101, line 102, and then there's a legend most of the time with those components on there. So if you're looking for rack a compressor 5 contactor, it'll show the lines everywhere it's on there. It'll stay in the legend 102, 107, 115, everything that's associated with that. Like when the electrical engineer draws that up, it the AutoCAD auto grabs it and puts that in there so you have a legend so you can look through these. Now it makes it a lot easier to troubleshoot when you know what lines to look for, or so you're not looking through a 30-page wiring diagram or booklet trying to figure out where all the lines are on this because it may be pages in between. So that's why what you're going to see with most of the time with us is you're going to see ladder diagrams. Ladder diagrams are easier to troubleshoot. And then what I always tell guys is come down the sides. find your point A and point B, start at the switch, and then you're going to move from, I always go left to right. So I'll move across, I'll go through each one, and then I'll find my load, and then I'll go backwards through there to the left and just keep looking at it backwards till I find it. And then the way I troubleshoot it is I'll start on L2, which generally goes right to your load. You're going to make sure you look at the diagram, make sure it doesn't. It does. You have nothing in between L2 and your load. You're going to put your meter on L2, and you're just going to hopscotch across every safety and contact from with the meter lead going across to L1 to figure out where you're losing your power. Now that is the easiest way to troubleshoot a line diagram or a ladder diagram. I'm sorry.
No, you're fine. Well, one of the things that I was going to say is sometimes being able to, let me put this up here real quick so I can look at it at the same time. Entire screen, no window. Here we go. So I can't find the thing with the symbols, but like example, if you're trying to diagnose this compressor circuit, a lot of times you'll say to someone, "Hey, I can't have my meter lead all the way over at the common." A lot of times you can pick a common up that goes directly to the other side, basically your neutral of the circuit. So the circuit that I have up here right now is a 208 230 volt circuit. So if you're trying to measure and do the hopscotch method, you could potentially just be on what this would be after the contactor, because that should go directly to ground at that point, or I'm sorry, directly to neutral, and then basically take your meter lead and start here, and you have it in between 0 and 10 right here, and basically just go through. Okay, don't have 208, don't have 208, don't have 208, have 208, and then you could basically figure out what part of the circuit is actually open with still having your secondary meter lead on a device that is utilizing the L2 in order to figure out what part of the system is open. Now remember, anytime you measure across a switch that is open, you should get the source voltage.
Yes, but if you're going to L2, you're gonna read zero volts.
Yeah, if you're basically, because you're not, what's your meter really doing, right? It's measuring the potential difference, right? So if you're on the same line, so if I'm on number 10 here and I'm on the yellow lead right there, I'm basically gonna get 0 volts. If you go across a load, whether it be an inductive load or a resistive load, I should get the source voltage. So across this contactor, I should have 208 if it's all the way energized. The other thing is to also notice that every single one of these branches always has a load. Doesn't necessarily need a switch, but definitely will always have a load, because if we didn't have some sort of load, so in this example right here, this load right here would be the actual module, right? It's getting powered from L and N, basically 208 volts. And if I didn't have this module here, I'd have a direct short to ground. And this line right here, I have the crankcase heater has a load. In this line, I have the unloader valve. And this load, I have the module power for the Delta Pi monitor, the Delta P2. If I have the oil fill relay here, I have the compressor contactor here. I have the time delay on this line. So every single line here, I have some sort of load that's able to take that voltage, not necessarily needing a switch every single time. Because look right here, right off of here, off of terminal 0, going right to the L and N, there's no switch at all. So this module, this would probably be the compressor module within the Bitzer compressor, gets voltage all the time in order to be energized.
Yeah, so you bring up a good point about not being able to have your meter lead reach. So like when you're working on a compressor protector modules, oil safeties, stuff like that are a good place to get it. Now, pay attention to your diagrams if you're going to use an oil safety for L2, because they may be breaking that with a current sensing relay.
Mm-hmm.
So you don't want to grab L2 if you're doing that, because you're not going to have any power there.
Yeah.
The compressor's running. So just pay attention where you're doing it and look at your wiring diagrams before, but tracing that out, and then if you're working on something without a diagram and you're trying to like trace things back or you're trying to figure it out, a lot of times, so like I will start at the beginning, make sure on L1 and L2 I have power, make sure I have good voltage there, and then I will start from the load and go backwards. Start from a load. This is what you're looking at. Like if you're trying to find something and you're looking at a compressor, trying to figure out why it won't run, you're going to start at that diagram, start at the load. Okay, you're going to say this is the contactor I want to turn on. Okay, I'm going to go to my right. What is on the right? Is it just L2? Is there switches? Figure that out. Then start working your way backwards on the left. Figure out what is shutting that contactor on and off. What is driving that load? So if you can't figure out, what everything is in there, start at the load and drive your way to the sides. Go right first because generally that's just usually your L2 power or your other leg of your control voltage. To the left is usually all your safeties and operating loads. I'm sorry, operating switches and stuff like that. So start on the load you are trying to drive and work your way back till you figure out everything that's in there. I mean, think of electricity like pipes. I mean, you're moving electricity like a pipe almost, like a pipe moves water. And you're shutting off valves just like you would be switches and relays to move water around. Think of it like water. You have to make a complete circuit in order to drive something.
So if you look on the screen, I have the electrical symbols that Zero Zone uses. As you can see, you have the power phase monitor, you have the power distribution block, circuit breaker, fuse block, contactor. I don't have to read all of them off, but you guys get the point of knowing what each one of these things actually does. And then if you look towards the middle, you can see that there's a temperature switch that closes on a drop, and then there's a temperature switch that closes on a rise. And that's what I was trying to describe to you guys before, where you actually see where it's drawn, where the line that connects the two circles actually is connected. Is it connected towards the top? Is it connected towards the bottom? Same thing with the pressure switches. You'll see right underneath there, flow switches, time delay switches, level switches. So that would be probably like a low receiver alarm, something along that matter. Not an analog meter, just something that if it goes below, let's just say 15%, it closes a set of contacts. This would also be comparable to something you'd find almost in a liquid pump overfeed system that has the CO2 tree in the back. But you can see all the different symbols that they're using, the transformer, the motor, the fuses. And then if we scroll down a little bit further, this is even more helpful. Not only does it have a lot of the electrical diagram stuff on here, but it also has what are some of the what these letters stand for as far as what other components in the rack, whether it be a motor, whether it be an exhaust fan, evaporator fan. So it helps try to figure out the schematics a lot easier when you start getting down into the nitty gritty, trying to figure this stuff out, knowing that, okay, well, this switch, which looks like a pressure switch, is operating this fan. And yes, you might not know what the settings are, right? But at least you can figure out based off of what it was showing you what the schematic is trying to do. It'll make you understand the theory of that piece of equipment a hell of a lot better than just trying to go in blind.
No, 100% agree. Like you need to read the schematic and then read the notes. Like,
Like this right here. Right. So look, we're taking a 0 to 10 signal. And this is, if no one's have ever seen this before, this is the digital unloader that Bitzer used to use. Yeah, well, I mean, it controls the Bitzer digital compressors, right? And this one just so unloader valve one, unloader valve two. So based off of the signal that it gets up here is when it's going to initiate these two unloader relays, whether to load or not load.
yeah, no, 100%. Like going through all the notes on the schematics is a huge thing.
Here's another thing too. I believe this wire key color code will basically tell you if it's wire number 20 then that wire is probably going to be red. Anything from 20 to 29 is going to be red. From 30 to 39 is going to be yellow. From 40 to 49 is going to be orange. So utilizing some of this other shit that you find on these prints will also help you kind of understand that. And like every manufacturer has their own quirks, right? So Hill Phoenix, for the most part, where they use for their 208 circuits, usually black and red wire, right? But then if you look at their inside their prints, anything that's connected to a digital input is always in brown wire, brown 14 gauge wire. So that's a real good way to look. Okay, well, I know it's not that fucking wire that I'm looking for. I can move on to this next one because I know that that brown wire is just going to a digital in, right?
Yeah, I will say this: out of all the manufacturers, I think Hussmann does the best job with their electrical and their like the electrical schematics in their racks, the electrical layout wiring for all the compressors. I think they are the easiest to troubleshoot and they are the easiest for guys to learn on. For the simple fact that everything runs back to a terminal block. So you could literally stand in front of the compressor electrical and the schematics right to your left, and you
Yep.
could literally put your meter on terminal 10 and terminal 1. That's your power. Terminal 10 and terminal 3, that's the high pressure switch alarm. Terminal 10 and terminal 4, there's your CPC relay.
It makes it so much damn easier to understand that electrical drawing. And I'm pretty sure every single time it goes back out, when it comes back, it's a different color. So like
Correct.
you know what I mean? So like if you have a brown wire coming out, you might have a yellow and white stripey coming back from the low pressure switch. And then it goes out to the high pressure switch with a blue white stripey, and then it comes back with a purple white stripey, and then it goes you know what I mean? Like they all have the set way that they freaking wire the shit up, which just
And,
is
and
amazing.
and that's how I learned how my electrical, and that's how I got sharp with it, was working on Hussmann racks, because it was okay. I'm gonna do the same process over and over again, and I just that same, once you build that up in your head, you get that same process down. Like it starts becoming easier. Like it's a rhythm. Oh, like the biggest thing I see guys fail when they're doing electrical troubleshooting is they'll take their meter and go to ground,
Hmm.
and they'll get all wound up because, okay, I got 115 over here to ground. Well, I got
Hmm.
115 over here to ground. We got 115 over here to ground. Well, really, you're missing your other line of 208, and you're just going around in circles because it's back feeding through there, and it looks like you have 115 volts there.
Well, because you're basically measuring the voltage versus the potential, which is ground. Ground has nothing, so you have 120 volts. So no matter where you go, you're still going to measure fucking 120 volts. So real quick, just by looking at this schematic right here. Okay, so DO would be a digital output. It's basically a relay output on the energy management or BMS stuff, right? Now looking at the wiring color on the left here of the screen, bottom left, you can see that okay, you got wire 45, 46, 47, 48. So what is that telling you right off the bat? That means all those fucking wires are going to be orange, right? Every single one should be technically orange. So what's this circuit doing? So I don't know what's going to turn on the DO. You'd have to look at the sequence of operation, but I can tell you just by looking at this, the A stat, which I think would be an aquastat, hence why it says it right above, if that temperature, because that's a temperature device, if the temperature rises anymore, it's going to open up, which is going to de-energize the wire at 47, which is the heat reclaim valve. So what that would mean to me is that typically the digital output is controlling some sort of heat reclaim, probably fluid, the fact that it says aqua, and that aquastat would basically be a almost like a safety. So if the temperature gets too high because of a sensor, let's just say the sensor is reading 30 degrees on the heat reclaim. So what's the controller going to do? Well, it's 30 degrees. I got to heat the shit out of it. So it starts heating up. And then if God forbid that sensor is off, at least you have the aquastat there to open up as a safety. So it de-energizes your heat reclaim valve, which is in between 47 and 48, and then kills the actual water heat reclaim. So you see what I did there. I basically took the symbol that I know. I know what HRV means, what DO means, and basically took the theory based off of how that's supposed to run and transposed it into this is what it's going to be doing based off of this.
No, I mean, yeah, or you got that solid ass jumper right there.
Well, that's if you don't have the aquastat in there. Smarty pants.
Yeah. No, I mean that's 100% the way to do it. Like if you know what the symbols are and you could kind of throw this together, you could easily figure out what this piece of equipment's going to do. I mean, even if you don't have the sequence of operations, I mean, you're not gonna be able to figure out what the EMS is trying to do, but you could at least figure out mechanically and electrically what this thing is trying to do. Now, uh, another thing like to watch out for is like a lot of like control systems will use pilot relays. So they will have relays driving other relays. Now, the reason you see a lot of pilot relays are like, especially back in the day, like a lot of relay contacts on boards and EMS controllers aren't rated for the duty or the amp draw or the cycles that they're going to be seeing. So what they do is they use a pilot relay.
Hey,
So you have
what was the
what,
first thing you said?
the duty cycles or
I'm
I
sorry, I
don't
just wanted you to say duty again.
so they aren't rated for the cycles. So what they do is they use a pilot relay, like an ice cube relay, something that say you're driving a load that's like an amp or amp and a half. You don't want to put that on a CPC or a microthermal relay. Yeah, it can handle it. It can handle 5 amps or 3 amps, but it's not good for it.
Yeah,
And here's the thing: if you short that out, you lose a board. So you may blow a fuse, or you may burn up a relay contact point. Okay, it's a lot cheaper to burn up an ice cube relay than it is to burn up a $900 board.
I agree.
So that's where you see a lot of pilot relays coming in. I mean, it depends on what you're doing. You'll see a lot of pilot relays driving stuff outside the rack, so like external circuit stuff that's like out in the field where it needs to be isolated from the rack control. So that's where you'll see pilot relays. So a pilot relay is essentially a control relay driving another relay. So it's driving a relay. It's splitting up the wiring.
Let me.
So
Oh,
go ahead.
sorry. No,
Go ahead.
I was just gonna say I want to bring up this other schematic just so we can go through a little bit more theory
Yeah.
on how this rolls. I don't know why we didn't do this long ago. Window. Okay, so if you look at this schematic that I'm about to bring up here. So this is on a liquid pump overfeed slash cascade rack. It's a combination rack. Look, there's a double pole single throw switch. So that goes through this relay. I don't know what this relay does. It looks like it's some low temperature run proof relay. But you can see that if all these go off on oil failure, it actually then shuts down whatever this is, which is the lower cascade main liquid line solenoid valve. So the theory is if we have no compressors running because all of them have oil failed, then basically no matter what, it's not going to allow this relay to power up all these solenoids up here. So it basically shuts down the rack to make sure it just doesn't keep pumping liquid through the heat exchanger back into the suction, flooding the system out. So, like I said, trying to figure out what a lot of these symbols do and what some of these stand for. Like, so I've this is a fairly regular standard. You'll see this the OFR relay, the oil fail relay, but you also have to look to see what it's attached to. I've seen oil fail relays also attached to a high pressure switch. So the kid's sitting there pushing on the oil fail switch because the rack says it's an oil fail. The oil fail relay light is on and it's just sitting there just doing absolutely nothing. And then I get there because he's freaking out, and I hit the high pressure switch because I know once I saw the schematic and once I saw the rack, it utilizes the same alarm set of contacts. So most of the time in what we do, we don't really have a annunciator for the high pressure switch, right? It's usually just a two pole switch. Well, some of these racks, some of the older ones, they had a third pole that had an alarm set of contacts. Walmart's really big for this. They do that a lot. And so if you have a high pressure, it that same alarm set of contacts also goes to the oil fill relay. So that's what I'm saying. Just because it says oil fill relay, you have to look at the whole entire picture, the whole schematic to fully understand, make sure that you don't make a mistake like that.
Correct. And then a lot of manufacturers do a demand cooling and anything like Hussmann was big for that. They would label everything as oil fail relay, and then
Yes.
everything would be you'd have all the demand cooling, you'd have the compressor module alarm, you'd have the everything tied to it, high pressure, oil fail. So I mean, same thing. Again, just like jabbing safeties isn't a good thing. It's why you need to use your meter and electrically troubleshoot. That's why in the beginning, like, take your time. I see guys do this all the time. New guys get to a job site, the lights on. What do? They go grab their hand, they go jab it in the oil safety. Okay. Well, they didn't troubleshoot it. They didn't see what it looks like. That's when you should be troubleshooting it with your meter to teach yourself how to actually do this and how to actually go through it. Because what if that light's not there? I mean, you're gonna have to actually figure it out. I mean, you don't want to go just jabbing safeties in, especially like I see it a lot of the guys will, oh, I pushed the high pressure and I pushed the oil fail and I pushed the demand cooling, and now I don't know what it was off on.
Say
That
that
is
one.
right.
What's that?
But sorry, it's raining like crazy, so my internet's glitching.
No, I was just gonna say it again because it sounded like you broke up for a minute.
So like guys will get on site, especially newer guys, and they'll jam the high pressure, the oil safety, the demand cooling, and they'll start resetting them all. And then by the time somebody gets there to help, they don't know what it was off on. They
Gotcha.
don't know what the actual like fault was.
I gotcha. Yeah, your internet's starting to fucking fizz out.
It's raining sideways.
I thought maybe your kids were playing Fortnite.
No, no, the old Elon Musk internet doesn't like the rain.
No, you know what? Let's end it here. I think what I'm going to do is I'm going to make something going into different manufacturers, having examples of different wiring. I think that would be a good video to make, and then we can basically use pointers to try to show how we would diagnose and where you would potentially get that voltage.
I think that would be a good like 4-part series. We can do one on Hill Phoenix, one on like Husband Rack.
Fuck yeah, let's do it.
I think that'll turn out good.
Yeah, let's do it.
Yeah, my internet's fucking shitting out.
All right,
All
guys.
right,
Thanks for listening. Have a good night.
easy.